In this problem, we have to find, here they have given F vector. The first one is find del dot F vector. So del dot F vector is nothing but divergent of F vector. Divergent of F vector, how to calculate means that is equal to dou by dou x of F1. F1 is nothing but I component, that is 3x square, plus dou by dou y of F2, that is j component 5x y square, plus dou by dou z of F3, that is xy z cube. So here the differentiation with respect to x is 6x. Here we are doing partial differentiation with respect to y. So x is the constant. So write 5x as it is, y square differentiation 2y. Here the partial differentiation with respect to z. So x and y, both the variables are constant, write as it is, z cube differentiation 3z square. So that is nothing but 6x plus 10xy plus 3xy z square. Next, they are asking at the point. Okay, in the question, at the point we have to find. At the point 1, 2, 3. So we have to find the value at the point. At 1, 2, 3. Substitute x equal to 1, y equal to 2, z equal to 3. So what you will get? 6 plus 20 plus 52. So which is equal to 80. So this is the first one. Second one, del of del dot f. Del of del dot f means that is nothing but gradient of divergent f. Okay, that is the meaning. Already we got divergent f. This is our divergent f. So write del of divergent f is 6x plus 10xy plus 3xy z square. Here, how to find a gradient means it is a summation I vector into dou by dou x. Dou by dou x of 6x plus 10xy plus 3xy z square. So, which is equal to I vector into differentiate partially with respect to x, this function. So, 6x differentiation, 6 plus second term, 10 and y are constant. So, write 10y, x differentiation 1. And third term, 3y is a square. That is constant. X differentiation 1. Plus j vector into dou by dou y. Partial differentiation with respect to y. So, first term is 0. Second term, 10x constant. Y differentiation 0. Third term, 3x z square. Y differentiation 1. Plus k vector into dou by dou z. So, first term 0. Second term also 0. Third term, this 2 is constant. Z square differentiation 2z. So, we will get 6xy z. Okay. Next, we have to find at the point 1, 2, 3. Here substitute x is 1, y is 2, z is 3. So what you will get? I vector into 6 plus 20 plus 54 plus j vector into 20 plus x is 1. So 10 plus 27 plus k vector into 36. So which is nothing but 80i plus 37j plus 36k. So this is our gradient of divergent f. Third subdivision is del cross F. What do you mean by del cross F? Means it is nothing but curl F. Curl F, how to find? Here the first determinant, the first row is ijk. And the second row is derivative, dou by dou x, dou by dou y, and dou by dou z. And the third row is ij component of the given f vector. Here the f vector is this one, that is 3x square, 5xy square, xyz cube. 3x square, 5xy square, xyz cube. We have to expand the determinant I vector into dou by dou y of this one. So that is xz cube minus dou by dou z of this term, that is 0, minus j vector into dou by dou x of this one, that is yz cube, minus dou by dou z of this one is 0, plus k vector into dou by dou x of this one. So that is 5y square minus dou by dou y of this one is 0. So this is our curl F. That is curl F is nothing but x z cube I vector minus y z cube j vector plus 5y square k vector. Next, we have to find at the point what they are asking at 1, 2, 3. So what we will get? 27 I vector minus 54 j vector plus 20 k vector. So what is the fourth subdivision? The fourth subdivision is del dot del cross F. Fourth one is del dot del cross F. So del dot means divergent of, del means dot means divergent, cross means curl, curl of F vector. So already we got curl F. So curl F is nothing but now only we got this one, xz cube I, xz cube I vector minus yz cube j vector plus 5y square k vector. See how to find divergent of this one means it is dou by dou x of I component, that is xz cube plus dou by dou y of j component, that is minus yz cube plus dou by dou z of k component, that is 5y square. So dou by dou x of this one is z cube. Dou by dou y of this one is z cube is the constant. Here we are having minus sign, minus z cube. Y differentiation 1. Here there is no z. So the partial derivative is 0. So remember, divergent is a scalar quantity and this is the one of the vector identities. That is divergent of curl of is 0. Next, the last subdivision is finding del cross F. So the fifth one is del cross F. That is curl of F. So curl of, already we got our curl of. What is the curl of? That is I vector into x z cube minus j vector into y z cube plus k vector into 5y square. Now we have to find out the curl of this vector point function. So here nothing but the determinant. The first row is ijk and the second row is the derivatives dou by dou x, dou by dou y and dou by dou z. And third row is I component, that is xz cube, j component minus sign is there, minus yz cube and k component, that is 5y square. Here nothing but we have to expand the determinant. I vector into dou by dou y of this one. So 5y square, that is 10y, minus dou by dou z of minus y z cube. So that is minus 3y z square, minus j vector into dou by dou x of this one is 0. Dou by dou z of this one is 3x z square, plus k vector into dou by dou x of this is 0. Dou by dou y of this one is also 0. So that is I vector into 10y plus 3y z square plus j vector into 3x z square. So next we have to find at the point 1, 2, 3. So substitute x is 1, y is 2, z is 3 means we will get the answer 74 I vector plus 27 j vector. So next problem, if r vector is the position vector of the point xyz with respect to the origin, prove divergent r vector is 3, curl r equal to 0, del of r power n is equal to n into r power n minus 2 into r vector. See this problem here, they have given our r vector is nothing but the position vector of any point with respect to the origin. So we can write r vector as xi plus yj plus zk. Okay, here the first one is we have to find divergent of r vector. That is very simple one. Dou by dou x of I component, that is x, plus dou by dou y of j component y, plus dou by dou z of zk component, that is z. So which is nothing but 1 plus 1 plus 1. So which is equal to 3. So next we have to find curl of r vector. Curl of r vector is nothing but the determinant. The first row is ijk and the second row is the derivative dou by dou x, dou by dou y, dou by dou z, and the third row is xyz. Xyz is nothing but the ijk component of our r vector. Okay, now we have to expand the determinant. So I vector into dou by dou y of dou z is 0. Similarly, dou by dou z of y is also 0. Minus j vector into dou by dou x of z is 0. Dou by dou z of x is 0. Plus k vector into, here I am writing, that is k vector into what is the dou by dou x of y minus dou by dou y of x. So it is also 0. Partial derivative with respect to x means other variables are constant. So y is constant. So the derivative is 0. So curl r equal to 0 here. Here the next part is to find del of r power n. Del of r power n means nothing but gradient. They are asking to find gradient of r power n. So here how to find gradient means I vector into sigma, I vector into dou by dou x of r power n. So sigma into I vector into, we have to differentiate partially with respect to x. So r power n differentiation is n r power n minus 1 into dou r by dou x. This part is very important one because r is depending on x. So don't think r is the independent variable. So here we have to calculate dou r by dou x. For that, here the given r vector is xy plus yj plus zk. And r equal to the modulus absolute value, that is modulus of r vector, that is root of x square plus y square plus z square. When we squaring on both sides, we will get this one. So here when we differentiate partially with respect to x, we will get 2r into dou r by dou x is nothing but 2x. That is dou r by dou x is x by r. Similarly, dou r by dou y is y by r. Similarly, dou r by dou y is y by r, and dou r by dou z is z by r. So we have to substitute this one in the our problem. So here what we are having, summation I vector into n into r power n minus 1 into x upon r. Now we combine this r and taking that one outside, it will become n r power n by 2 summation xi. Now we can open this sigma. When we open the sigma, it is nothing but xi plus yj plus zk, which is nothing but our r vector. The next problem, prove that f vector equal to okay. So here they are asking to prove this F vector is solenoidal and retrotational, and also to find the scalar potential. So how to prove solenoidal means we have to find, we have to show divergent F is 0. So divergent F is nothing but dou by dou x of I component, that is 2x plus yz plus dou by dou y of j component, that is 4y plus zx plus dou by dou z of, here the minus sign is here, there for k component. So minus 6z plus xy. So now we do the differentiation. The first term differentiation is 2, second term is 4, third term is minus 6, so 0. So divergent F is 0 means F is solenoidal. Next, we have to find out the curl F. So curl F is nothing but the determinant I, J, K. The second row is the derivative. Third row is the given vector value function coefficient 4y plus zx minus 6z plus xy. When we expand the determinant I vector into dou by dou y of this one. So what is dou by dou y of this one is x minus dou by dou z of this one is again x minus j vector into dou by dou x of this is y minus dou by dou z of this term. So when we differentiate partially with respect to z, first term is 0, second term is y, z differentiation 1 plus k vector into dou by dou x of this one. So first term is 0, second term is z minus dou by dou y of this term. First term 0, second term z. So curl f is 0. So f vector is irrotational. Next, we have to find scalar potential. Scalar potential is given by the formula f vector equal to del phi. So here what is the f vector they have given? 2x plus yz I plus 4y plus zx j minus 6z minus xy k is equal to del phi. That is gradient phi is nothing but I vector into dou phi by dou x plus j vector into dou phi by dou y plus k vector into dou phi by dou z. Next step is we have to equate the like components. First equate I component. So we will get dou phi by dou x equal to 2x plus yz. Similarly, j component. This is the j component. Equate means dou phi by dou y is equal to 4y plus zx. Next k component, that is dou phi by dou z is equal to minus 6z plus xy. Here we have to find phi. From this derivative means we have to do the integration. See the first one, we have to do partial integration with respect to x. We are treating these two variable y and z are constant. So phi equal to the first term integration is 2x square by 2 and we are treating y and z are constant. So write y z x plus constant is we can write function of yz because we are treating y and z are constant. For the second one, we are do different integration with respect to y. So treat z and x are constant. So first term integration 4y square by 2 plus zxy. Here what we are treating constant f2 of x and z. Then third one, integration with respect to z, treating x and y, other variable x and y are constant. So minus 6z square by 2 plus xy z. Plus here what we are treating constant x and y. So when we combining all this, we have to write phi equal to, see here 2 get cancelled. So x square plus xy z. So here 2 get cancelled, 2y square. So no need to write the repeated terms. Okay, because we are doing the partial integration, no need to repeat. So no need to write this term again. Now we go to this one. So here it is minus 3z square. Again, no need to write this term plus. So this is our scalar potential.